We're here. Okay, so today we're talking about standard deviation. The symbol for standard deviation is this Greek symbol, sigma. Kind of weird looking. Looks like a pear that's been turned on its side. And then variance. Variance is the standard deviation squared. So sigma squared. So these are two measures showing how much data values deviate from the mean, from the average. Measure of variations describe the data in a data set or how they're spread out. Variance and standard deviation are two examples of measure of variation. So variance and standard deviation. Now, let me see if I can find one really quick. I meant to yesterday. Give me 1 second. So this is what the bell curve would look like. And they're saying with standard deviation, this is the middle. And then you can split the data up into certain percentages. So 68% of the data is going to be within one standard deviation of the mean. 95% is within 2 standard deviations. And then 99% is within 3. So the point is, if we know a mean and we know a standard deviation, we can kind of see where all of the data lies. Our goal for today is simply to figure out how to find standard deviation, and then we'll probably be using that to compare data in the next couple days, I'm assuming. So the process to, oh, that's nice. Cute. I was wondering what that was. Yeah.
You have Westlake pictures, and then I accidentally copied 2 of them because I did the night before.
Okay.
So I hid it in my teacher's computer in her notebook, and so now it's passed on in this class.
Thank you for that. I saw it down here, and I was afraid that it was a random picture of me, so I didn't want to open it. I just saw a face with dark hair. Okay, so here's the formula for standard deviation. It's kind of ugly. First thing we have to do is find the mean. So that X with a bar over it is now the symbol we will use for mean. We need to know the mean. We need to know how many values are in the data set. The very first thing we'll do is it's really a miserable process. You take every data point and you subtract the mean. So you have a whole list of differences. Then we have to, so if we look at this equation, then we have to square those differences to get them all positive. Then we have to add them all up. And then we have to divide by however many there are. That gives us the variance. After that, we take the square root and we have the standard deviation. At least I didn't lie and tell you this was fun, right? Right now? Yeah, go for it. So it is a miserable process. We've broken up into these little charts to hopefully be a little helpful. So I'm going to start by listing all of my X values. 6.9, 8.7, 7.6, 0.8, 9.0. It wouldn't necessarily help. Then we need to find the average. So, on your own, find the average. First one that gets average, yell it out. Everybody should be trying it. It's like a race. $7.4, that, by the way, is the only way I can get my children to do anything in a timely manner. Who's going to get their seatbelt on first? It's a race. Who's going to get dressed in the morning? It's a race. Brush your teeth. It's a race every day. Oh no, we do it every day. Until one of them gets mad and says, it's not a race. Okay, so now what we're going to do. This right here means I have to take my x value and subtract the average. So 6.9 subtract 7.4 is, nope, did that wrong. Negative 0.5. And while we're here, we can square that and get 0.25. So I really don't care if it's negative or positive, because when I square it, they're all going to be positive, right? Yeah, so 8.7 minus 7.4 is 1.3, and 1.3 squared is 1.69. So we have to do that for all of them. 7.6 subtract 7.4 is 0.2, and 0.2 squared, 0.04. 4.8 minus 7.4 is 2.6. Negative, but we don't care about that. Square that, we get 6.76. Subtract 1.6 on that one, and square it, you get 2.56. Okay, so let's go back to our equation. We start with listing our x values. We have to find the average. We subtract those, then we square it. What do we do next? What does that symbol mean? Sum, right? So now we add them all together. The last column. I got 11.3 for the sum. So I'm going to find the variance. That's sigma squared. We take the sum, divide by however many there are, which is 5.26. So that's variance, which we don't really use number. But the variance, let's get the standard deviation. To get the standard deviation, we take the square root. And you 1.5 roughly. Same? Yes. It's how many their data points there are. That's it. So let's say the mean we did, the variance did, and the standard deviation of each data set. Yep. Yep. With the square of 2.6. Standard deviation. So again, start by listing the data point. Have to find the average. It's a Ray, do it first. $6.8. Then we subtract them. So when you subtract the first one, you get a 17. And when you do that, $13.8. You subtract next one. Negative 0.8. Third is 36. 4.8 squared, 23.4.
72 squared, 51.8. And 2. The last one. 12.2 squared. We add them all total. Total, you're at a 6.84. That total, what do I do? This time, now we divide by n, right? We get averages. Third, thank you. 94 divided, because that many there are. And you get what? 1.1. Then if is that to deviation square root at about 10. So there we have it. It's very mysterious. That provided if you want. Try part B on if you lay some answer for part skip. Okay, I just feel give it to you. No problem. My own, well, it's answers.
When you're done, you should have 12 data points, because there's 12 weeks. So there are instructions on the top of what to do. So we've just done step 1, we've edited the list. Then we're going to go back to stat and go over to calculate the calc. This is a one variable statistic, so you just push enter and you push enter again. And it gives you everything. The X bar on top, that's the average. 1992.3. The summation, we're going to ignore those couples. The sigma X down here at the bottom, that's the standard deviation. So if I were doing this problem and I was using a calculator, find the mean and the standard deviation, well, the mean is 1992.3. The standard deviation is 61.8. Done. So again, we're gonna, so stat, you'll use edit if you want to put it in your list, or calc, and it's one variable, stats right here. And some of them have like parameters underneath, you just have to enter all the way through it. Mine looks like that. That's it. So let's try part B, see if we can get the same information. Yeah, that's better. Okay, so it's all entered in, stat, calc. Oh, just kidding. I entered mine into list 2 this time, so I need to specify that I'm pulling my data from list 2. That looks better. So my average, 12,287.6. My standard deviation, 289.5. That means if I take my average and I plus or minus the standard deviation, the 289, 68% of my data is going to be in that range. And if I do it again, 95% of my data will be within that range. So it's a way that statisticians can use the mean to figure out where most of the data is coming from. It'll tell you how spread out your data is, how clustered together your data is. The smaller the standard deviation, the closer your numbers are together. We won't go past 10. No, I'm not sure, but we can see if we can figure it out. Any other calculators not going past 10 digits? Okay, we'll see if we can fix it. I don't know how, but Google always is a good resource, so we'll figure it out. Okay, let's move on. Like we said at the very beginning, a bell curve diagram helps understand normal distribution of data in a population. about 68% of the data are within 1 standard deviation of the mean. About 95% are within 2 standard deviations. And about 99% are within 3. Bell curve, yeah. In the data list, every value fall within some number of standard deviations of the mean. For example, if mean is 50 and the standard deviation is 10, then 68% of the data would fall between 40 and 60. That's 10 away on each side of the average. So that's 1 standard deviation away from the mean. So if we kept going, 30 and 70 would be 2 standard deviations away. 95% of the data would fall between 30 and 70. 99 would fall between 20 and 80, and so on. Fix it. Okay, so let's jump down to the example. 68. So it's 68 in the first standard deviation, 95 in the second, 99 in the third. Anything after that is probably outlier if it doesn't fall within the 3. Okay, in order to use this, you need to know the data values, you need to know their mean, and you know their standard deviation. It's helpful to know how many standard deviations would include all the data. You can draw a number line, plot the data points, and mark intervals of where things go. So, the first thing we want to do, and I'll let you do it on, is find them in the standard deviation. So this is one chance to practice on the calculator. Ignore the 1 through 15, plug 4, 4, 7, 10. Carry yours because we get the same. That's what I did yesterday, but perfect. Alright, next thing we're going to want is we're going to plot the lowest value is 3. Highest is 15. Or 5,
7, 8, 10, 12, 13, 15. That's all we need. Okay, how many do we have? The 2 that I see. How many 4s? Fives. 1, 1, 11. No, 12, 13, and 14. You said this was about 6. Fall. Right. Standard Deviation is 3. So, if I 7 points, I 2, and 8 is first. Is that right? 7.3. One stationary. So, if I 3 point, I get 13.7.